Hello everybody, I'm William Loring from Western Nebraska Community College. I'm an instructor. I teach information technology, cybersecurity, and computer science. The title of my project, which I've had for several years now, is Enhancing Computer Science Curriculum Using Off-the-Shelf Technology Projects to Enhance Whole Brain and Balanced Learning. Let's take a look here. So the traditional computer science curriculum usually is desktop web-based applications, traditional linear problem-solving activities. They quite often focus on computer science only, which is not bad, but let's add in some soft skills. And typically we do a deep dive into a single programming language. So what I've done in cooperation with Southeast Community College and STEM Connect is we've diversified our languages into at least three: Python, Java, and C++. We're also working on off-the-shelf electronics projects and open source electronics projects. So here's a couple of them. We have TIR, the Mars rover up there, which is being worked on by 9 to 10 students. Right now we're down to one main team of 3 or 4. So we try to, with our curriculum, work with agile development, which means we try to turn around a working release every week. We work in teams, multiple languages. We're integrating off-the-shelf and open source. So for instance, in robotics, we have the MBOT, the GoPy Go 3, which are off-the-shelf kits. Thor the Robotic Arm is a total open source project. You can see him over there in the corner behind my picture. That's a picture of not ours, but the original idea. And TIR the Mars rover is our current project we're working on this spring. We also have a NASA fellowship this year, which is always good. I hope that continues. We have a Cougar Creation Station, which has been funded by several grants, including the Nebraska Space Grant. It's a cross-discipline makerspace. We have computer science, engineering, and math and science people coming together. Here is Thor the Robot Arm. A video is worth 1,000 words. This is our completed robot, and you can see there's a little 3D printed hippo down there that we're trying to get down and grab a hold of. Let me just zoom a little ahead here. There he is. One of my students figured out how to hook up a gamepad control to it. And it's based on an Arduino board. Oh, there goes his friend, the hippo, lifting him up. There he goes. And you can see we did him in the Cougar colors with our 3D printer, one of which was purchased through NASA funds. We have a new 3D printer, a Bamboo, which was purchased with Math and Science and STEM Connect funds. And there he goes. So you can see Thor the Robot Arm is functional and blue and gold, just like our Cougar colors. Moving on to TIR, the Mars rover. You can see this is the main team, 3 of my students. Here's our Mars rover. We stuck with the same colors that the original person had. You can see there's wires hanging out of the bottom. Well, we just got to the point where we got the motors and the wheels and the servos, and we still have some testing and work to do with those. There's been several IT and engineering students that have come in and done things throughout this project. Everything from assembly to 3D printing to soldering. So these types of hands-on projects provide a lot of tool use, which I've discovered many students have never used tools before, so it's really a good experience for them. And it's helpful to have people from different areas working together. We have, over the past year, increased our social media presence. So we have WNCC IT Program Facebook page, a YouTube channel, and a GitHub where we have all of our NASA and other projects in. So we're promoting the college and Nebraska Space Grant and everybody. Well, let's take a look at the last work day we had with TIR. Tuesday afternoons are quite often our work day. Here's one of the students assembling. See, yeah, we sometimes have to get out the pink hammer because things get stuck, What's a creative space without a pink hammer? We have soldering, we have putting things together, we have wiring, we have programming, we have trying to figure out where things are supposed to go by the videos. We had to redesign, or actually Owen, the student you just saw, redesigned 2 of the parts because they didn't quite fit. One of the things that happens with these type of projects is the bill of materials changes, or you get exactly the right bill of materials and they change how they manufacture the motor. Well, those are fun projects. They learn a lot. The other part that I've been working on is enhancing scaffolding learning activities across a 2-year integrated curriculum. So I'm not doing the traditional computer science deep dive into a programming language because my students, I never know where they're going to go and what they're going to end up doing. So I try to expose them to multiple languages and concepts, which does work. I've seen a lot, and students will agree that the concepts and problem solving is what they're learning, not memorizing the syntax. We also have team-based semester projects which build team skills. Team skills and soft skills. Your technical skills may get you the job, but team skills and soft skills will get and keep a job for you. It's true in anything. We do Python as a beginning class. Oh, this says second semester curriculum. Python's very easy to learn. We go through, we do APIs, we do a little bit of everything. We expand on programming concepts. We do semester projects in each 3 of our computer classes. Python is also very easy to learn object-oriented programming in, and many other concepts. So the idea of this is that you start with prior knowledge, and then you have new understanding, and then you go back and do the same thing. Here we are going with Python. Oh, then we start out with Java, same stuff, but a little more complex, then C++. So they've hit the concepts 3 times, and of course each time I add a new language, I go a little bit more quickly because they've already got the major idea of the concept from Python. This has been developed from the STEM Connect grant in a partnership with UNL and Southeast Community College. So, yeah, this is Intro to Computer Science. I do each of my programming courses with OER materials, so it doesn't cost the same thing. This is basically going through the same thing. We reintroduce and expand on programming constructs at a deeper level. Modern software engineering does use multiple languages, so I think they need to get used to switching gears. And then, of course, with this Intro to Computer Science and Computer Science 1, we move more deeply under the hood of what is actually going on. And here's the final one, Computer Science 1, again OER, which allows me to modify and change as I go. We get deeper with Python, Java, and C++. We introduce maker projects. We have a full stack development project with SQL. We're working on actually using SQLite with, at this point, Python. Everybody's doing it with Python. We have one team that's working on doing a website with Flask using SQLite and authentication. It's going to be quite an interesting project. Well, what this does is it gives everybody a chance to experience learning in the way that works for them. It's a hands-on approach. We have fun projects, VR. Anytime you can stimulate students to do something creative, that does what's called whole brain learning and thinking. So what happens is then they have to cross between their logical part of their brain and their creative part of the brain, expanding that little superhighway that goes between them. Any skill that you develop needs a creative piece. We work on building soft skills. Try to integrate our concepts through the entire curriculum. I work with one other instructor, and we touch base all the time on, okay, how can we introduce this in this class, follow up with it on this class. We try to have a faster learning feedback cycle. I try to provide feedback as soon as I can. It is, I think, a more efficient transfer of knowledge. I think, or at least I've heard from my students, that they are ready to walk into the next class as a last semester sophomore or junior with good preparation. And I try to have all my assignments have fun. We try to explore fun programming concepts because at the same time, you can have fun and learn. Well, I can't have you ask any questions. These are just some of our students. There's Buddy, he's participating in a lab. I don't know if he's going to pass the test or not. Regardless, to encapsulate or revisit, I'm working with off-the-shelf and open source technology projects across disciplines, plus looking at scaffolding at least 3 different programming languages together along with other experiences to prepare my students for the workplace and for wherever they go next. I appreciate your time. I hopefully will see you live next year.